Hi everyone! In this video tutorial, I'd like to take a look at electrophilic aromatic substitution reactions, specifically the nitration of benzene. So in this case here, we have benzene, and benzene is an aromatic compound, which means it's a particularly stable compound. And with and of itself, it's not particularly reactive unless it's given a strong enough electrophile with which to react. This group here, our nitric acid, is not within itself a great electrophile. So what we're going to see is there's going to be a reaction between these two such that an electrophile is generated that is attractive enough to motivate the benzene to react with it. And in that reaction, we're going to be adding this NO2 group on, and it's essentially substituting out for the hydrogen that was previously there. Okay, so now let's take a look at the mechanism for this reaction. So the first step is actually going to be the generation of the electrophile that'll get this reaction going. Because remember, on its own, nitric acid is not strong enough electrophilically to get the benzene to attack it. So what we're going to do is essentially create a protonated nitric acid. So we're going to see that over here, this oxygen with those lone pairs are going to come and attack this hydrogen attached to the sulfuric acid. Because hydrogen can only have one bond at a time, that'll help to motivate this bond breaking over here. So then what we see that we make now is we're going to have this H2O group here attached to the NO2. So essentially, right, that oxygen now has a positive charge on it, which oxygen would prefer not to, as it is quite electronegative. So that's going to stimulate this bond to break. But in this case, both of those electrons are going to get transferred onto that oxygen. So here you're going to create the water group that was kicked off here. And now you have this NO2 positive, which is a great electrophile to use for the rest of the mechanism. So let's take a look at what else happens. Okay, so now we can take a look at the electrophilic aromatic substitution step of this nitration. So over here we have our benzene, and then this is the electrophile that we made in the preceding step. And now this electrophile is strong enough to motivate the benzene to actually break its aromaticity, add it on, and then substitute it out for the hydrogen. So we can see here that these pi cloud electrons can come and they can attack that electrophile. Now this is an equilibrium step because we are losing the aromaticity, and that's not a particularly favorable thing to form. So we will find that there's an equilibrium between these two steps. But once it does happen, you'll now see that we have both the NO2 and the H joined to this carbon. This one here has a positive charge on it. So now you're going to have some kind of substance in your solution that can act as a base, and that base will come and extract that hydrogen. When it does, that'll allow this bond to break, and both of those electrons will come, and we're going to reform our compound, benzene, and now we have reestablished the aromaticity, which is why this is a one-way arrow, because it's a very favorable step. And that's pretty much what you need to know for the mechanism of nitration of a benzene.